Well, hello friends, welcome to Suraj ke classes once again. I'm your friend Suraj Sharma. We are going to have a video on the topic, right? So what is the topic? Now let's guess what the topic is. This is also again we are representing something very useful for you for your daily life, how we can connect the electrical engineering to it. So let's have it. See, whenever you are passing through your, society road or somewhere or highways, there is a pole like this. You must have seen this pole, and there is one device. This looks something like this. Whenever you're traveling, passing, and you must be thinking what this is, why this is used, and why these many heavy wires are used here, what this spring kind of structure is installed, and how this thing is working. Well, I hope you must have seen, everyone of seen this type of device and must have thought that what this thing is and why this is used. So let's have the your curiosity meet to an end, that what this device is and how we can, how we operate this and why this thing is used. First, let me show you the view, the exact view. There are different kind of devices that are found in different countries. Actually, they are as per their country standard, electrical standard, they are designed, okay? But one thing that remains same, and that these poles and this device, okay? Now I'm showing you this. This is a typical Indian device. The name of this is transformer. Transformer, okay? The name of this is transformer. Now what these other things are, let me show you. This is called the bushings. What this is? Bushings. I might be, wrong with the spelling, but I am not wrong with the pronunciation of this. This is called the bushing. Okay. These are called the connecting lines. The three-phase lines R, Y, B. In many countries, U, V, W. So this may vary, but one thing that remains same always, and that is these three lines are representing for three-phase wire system or three-phase supply system. Okay, I hope I have made myself clear on this. Now next thing we are moving. What these are? These are holding poles. Holding poles just to hold this a big bulky transformer on this, and for the purpose of transmitting the electricity. Now let's have more pictures of this, then we will come back to the explanation of this. Now let's have more pictures. So one thing is clear in our mind, that this is what? This is the transformer. Okay, and these are bushings and wires and everything, the accessories of transformers, right? So this is one other type of, construction, and this is not, of India. This may be of abroad, or maybe European transformer, or maybe US side. Okay, and how this looks. See, this is having very different design, and this also looks more bigger than what this is on our left side. This is very much big. So what this is also a transformer, but this is not the distribution transformer. Actually, transformers are also divided by the distribution. So this is not the distribution transformer, this is the power transformer. What this is? Power transformer. Okay, I will explain you about the both of these transformer, but first you be patient and just look at these pictures very closely, neatly and carefully, so that whatever I explain to you in this video onwards would be very much clear in your mind, and you will be able to learn everything, grasp everything properly. Now let's move on to the other picture. So this is also the transformers in abroad, how this looks. This is the abroad transformer. I mean, this may be of any country. I don't know what country of transformer this is, but I'm very sure that this is not of Indian transformer or Asian transformer. This is of European country transformer, maybe Russia, US, America, Britain, any country, but this is not Indian transformer. Now let's, okay, we are having enough views. We are coming back to it. Okay, we are coming back to it. So I will give you first basic information of this. Then after we will move on to the principle of working of this. Now basic information, what these informations are. Okay, let me explain it to you. First of the most basic thing, why the transformer? Why this transformer? And why I mean, why transformer is used? Why transformer? What the transformer is and why this is used? Transformer is nothing but it's a transforming device. Okay, this is transforming device. It is absolutely technical electrical device. Okay, this is absolutely electrical device. There is no electronics involved in this. There may be few part of it, but it is kind of almost purely electrical device. Okay, so what happens is, now I tell you the scenario. What happens is, this transformer that I'm showing you, this is the distribution transformer. Okay, now I also showed you the power transformer. Now first let me explain the distribution transformer. Okay, so now let's assume this is your colony or this is your entire region or town where you are living. Okay, there are a small number of houses. Okay, there is a small society or your town road. There are more number of houses, and you must have encountered this type of transformer out of your colony or of your house at the entrance or maybe at the ending or wherever the lines are going. Like there are poles, see, like this is nothing but a pole. Okay, I hope you understood this. This is nothing but a pole. Okay, so there are poles where 3 wires are going, 1, 2 and 3 wires are going. I am very bad at drawing. I have already mentioned in my last videos as well. So don't go to my drawings, but try to understand the concepts. Okay. So these are lines. One is R, one is Y, one is B. You may indicate or you may denote it with UVW as well. I have definitely no issue with that. But generally in India, what we are denoting, we are denoting it with R, Y and B. Okay. So there are 3 lines and this is nothing but poles. This doesn't look like pole anyway, but this is pole, just consider. Okay, these are poles. So you are having 3 lines, okay, R, Y and B, and these are carried out by these poles, or there is a single pole only. This is single pole and all these 3 wires are carried out on this only. And let's assume this is of 11 kV line. In last video I have already covered what is 11 kV, what is 22 kV and why these numbers are varying and what is the use of it. I have already mentioned. Again I'm mentioning here that this 11 kV, 33 kV, these are the distribution standards. This may vary due to distance, due to any area capability or any other region, but these are. So let's come back to the point. So this is 11 kV line. This is outside of your region or your town or your society, the 11 kV supply that is coming. Okay, now this 11 kV is carried out by some poles. Okay, there are some lines, there are some transmission lines where this 11 kV is being carried. Now there is one device which is called a transformer, which is installed outside of your society. Let's assume. Now what is happening? This 11 kV is applied to this transformer, and we are well aware that these houses of your society, the domestic supply domestic supply standard voltage and frequency is 230 volt, okay, 50 hertz supply. This is your standard voltage level that can be used for any of your Indian electrical appliances, okay. Let's say if you're living in country like US, so the standard voltage is 120 volt and 60 hertz, and in entire Europe, I think European standard is also same, that is 230 volt 50 hertz. So whenever this 11 kV is applied to this transformer, this is directly transforming this 11 kV to 440 volt or 415 volt, okay. Now these 415 volts are in three phases, okay. These 415 volts are in three phases, R, Y and B. There is one more wire that we are connecting here, that is neutral, okay. Now whenever we want to have 230 volt, then this 415 volt can be connected directly to neutral and it will give you 230 volt, okay. So this is the concept by which we are getting 230 volt in our house. I hope this is making it very clear that how we are obtaining 230 volt from this 413 volt, okay. So this is the concept how this transformer is giving you 230 volt at your house in India. In any other country the concept remains same, only this, you know, output voltage would differ. Here 415 volt, there may be some different voltage level obtained at the secondary of the transformer. I hope this thing is clear to you. Okay, now some basic things I need to cover here. How this 415 volt is happening, how the operation of the transformer is happening, that everything I am going to cover onwards in this video. My only request, just don't leave this video, you just have to watch it fully. Now let's move on to the other thing, that is your bushings. That is nothing but your bushings. I am going to cover it here, okay. What these bushings are, this is also bushings. Now what is these bushings? What is these bushings? Bushings are nothing but hollow insulator type construction, and I think you all know now what the insulator is, because in my last video I have already covered. So everything is just interlinked. You have to watch, keep on watching every single of my videos so that you don't lose any of the important concept. Now see, these are the bushings. These are the bushings. Why this is called hollow insulator? Because the construction of bushing is something like this. This is your bushing and it is hollow inside, where you can have the conductor pass through it, like these wires are passing through it inside, and at the surface it's an insulator, so that the electricity connection is very insulated from outer region, okay, so that you don't have the sparking. Because the voltage level we are talking here, that is of 11 kV, 33 kV, so these are big in number, and you don't want to keep any, you don't want to keep any negligence to, I mean, in order to avoid any accident or sparking or failure of this transformer. So these bushings are kept here just to provide the insulation to this conductor passing through these bushings, and you don't have any sparking through surface of the transformer or anywhere. So I hope the bushing concept is clear. So there are some other devices as well connected to the transformer that are not applicable to this distribution transformer, that also I will cover in my video in this onwards. Now what it looks like when you have the inside view of the transformer. So this is something it looks like, okay, this is something it looks like. So these are the windings. As I already told you that windings are there. So these are three windings. One is representing R, one is representing Y, one is B, or maybe U, V, W, as per your country standard. Okay, I hope this thing is clear now. These are the bus bars, okay, because it is carrying a huge amount of current, so that the bus bars are used so that to carry out the huge amount of current, because simply wires cannot be a solution for carrying out the current, because wires are kind of flexible as well. This bus bar stood, and they are very much appropriate for using current carriers. Okay, so this is how you can denote this. So this is like the transformer construction is from inside. There are some primary and secondary wires as well that I will explain you in this video onwards. Now let's have the explanation. I told you one thing, that there are many things which we missed in the last transformer design. There are different designs of transformers that actually depends on their voltage levels, and transformers are, transformer a unit is what, like whenever you are going outside for purchasing any electrical appliances, so the unit for that electrical appliances is in what, watt, okay, but transformer unit is not in watt, it is in kVA. Okay, this is kVA, kilowatt ampere. Why this is in kVA, that will be also explained in my next or some other video. Just let me know if you want to know the details of this, because this should be very technical, and I don't want to go in that technical in this video right now. Okay, so one more accessories that is connected to this transformer, this is called what, conservator tank. Okay, now why this tank is used, so I will explain you everything why this tank is used. Now see what this thing is. This is transformer, and this is what, this is tank, and this is what, these are radiators. Now I will tell you first what is the conservator tank, then the radiators. Okay, see, transformer is a device like this. This is the tank of the transformer. I am going to show you a single line diagram of this. In my last photo, what I showed you, I will also explain you that. Okay, I am coming back to it. This is your core of the transformer. Okay, this is the core. Actually, this doesn't look like this. This is something like this. Okay, this is something like this. See, this is the core, the outside. This is the core where the windings are given, core of the transformer. I know this is going to be very technical, but I will tell you in layman language, a simple language, how these things are happening, so that you will come to know why this happens. Now first, the conservator tank. This looks like a tank where some liquid or any item is stored. This looks like a tank. You are right, this is a tank only. Okay, but why this tank is used? Transformer windings, the winding inside this transformer are always filled with some oil. This is oil that is surrounding the transformer windings. Now why oil? Why oil is used? Oil is a good dielectric medium, just to prevent any sparking or hazard through the windings or internal short circuiting. The oil is used. Oil is having a good capacity to resist any current sparking or any current spark or internal short circuits. So this oil is filled inside the tank of the transformer, and there is one conservator tank. This is your conservator tank. Okay, so now why this conservator tank? Actually, whenever the current is flowing through these windings, whenever the current is flowing, So that time this is heating up this core, and when the core is heated, then the oil is also heated. The core is heated, the oil is heated. When the oil is heated, the evaporation happens. Evaporation happens, okay? Evaporation happens, that means some gases are released. Gases are released. And to accommodate these gases and to accommodate the oil, there is one conservator tank. Whenever there is a situation, the core is heated much and the transformer core is not capable to handle this amount of oil, then this directly goes to the conservator tank. There is also one relief valve installed in transformer, but anyways, whenever there is a that kind of situation, then conservator tank would prevent the accident to happen, or to prevent the blasting of the transformer. The blasting of the transformer. One thing is also there is a breather, but this is not given here. But in power transformer, the breather is also given. So I hope the operation is clear now. I am coming back to the main working of the transformer. This is my last slide, and I will show you how this transformer works. Okay, we will also have a conclusion slide, or the conclusion we will also summarize what things we have seen so far in this video, and I will also show you that how these things are interconnected. So now let me show you the principle of the transformer working. Okay, I have already covered how this distribution transformer, any transformer, the principle of working is same. Either it's a distribution transformer or it's a power transformer. Okay, so the principle of working is same. So we are on principle of working of the transformer. Principle of working. So now we are on to the principle of working of the transformer. Now let's suppose this is the primary of the transformer, okay, and this is the secondary. I will also show you why the number of turns in this primary are more than the number of turns in secondary. The current that is flowing through this is I1, this is flowing I2, okay. The voltage that is applied V1, and the voltage that is applied here, that is V2, okay. This is very simple. The like you apply 230 volt to your electrical appliances, and the current that is flowing, that is of some amount. So same thing is here. The voltage whenever we are applying to some amount of current is definitely going to be flown through this, okay. And there is one more thing which is generated as a result of flowing of current through the primary, that is nothing but flux, which is denoted by this sign, flux, okay. The flux is also produced, okay. So now what is the principle of the working of the transformer? That this works on principle of mutual inductance. Now what this thing is, what is mutual inductance, okay. So see, what is mutual inductance? Whenever you are applying some amount of voltage at primary side, this is your primary and this is your secondary of the transformer, okay. So whenever you apply some amount of voltage at the primary V1 and this is carrying current I1, the flux will be produced, and this flux would be linked with the secondary winding. This is the secondary winding, okay. And whenever this is linking with the secondary winding and the circuit is closed, so the current will be also flown. This is your load, this is your house. Let's suppose this is your house that is connected to the secondary. So this is actually the load, okay. So this is your primary, this is your secondary, and this is your load, and this is how it is getting connected. I am not going in more technical, I am just talking in layman language, okay. Now what is the ratio? What is the ratio of primary and secondary? Now let's say I am taking a very simple example for you guys. You know how transformers are designed. This is very much important. Just concentrate here. I know this is you know making you feel very heavy to understand, but believe me guys, you have to watch this video couple of times to understand the concepts, and you know this concepts will help you lifetime if you understand this right away, right now. Now see, the Basic formula for the transformer is V1 I1 is equal to V2 I2. Okay, this is the basic formula of the transformer, that is V1 I1 that equals to V2 I2. Okay, so this is what the formula is, and how this formula works. Let me tell you how this formula works. See, as I told you, I am applying 11 kV that is coming from my primary side. This is my transformer, and at my primary I told you that 11 kV is coming, and on the other side that is 440 volt is going out. Okay, 11 kV that is my on primary side. 11 kV is nothing but 11,000 volts. Agree or not? You all know. You all know this is 11,000 volt, and there is some amount of current. I don't know. Let's say keep it I1 only, and V2. I'm getting what? I'm getting what at V2? This is 440 volt. Okay, and I2. Now see the beauty of this. Now if you want to find out the value of I1, this is going to be I1 upon I2, the ratio of I1 upon I2, which will be 440 upon 11,000. So I1 is going to be very less in number, where in case the I2 value will be very higher, and this will be lesser. See the beauty of this. Now voltage is higher here and voltage is lesser here. So ultimately the power P1 at the primary is equal to power P2. I hope the point is clear to you. The equation of power is V into I. For AC power we also add cos phi. Now let's assume the phi is unity. Cos phi is unity 1. Power factor is unity here. Then V and I only. If we are looking at this identical condition, see, then power equation would be V and I only. Okay, so the P1 is equals to P2. The two things in transformer always remain same. One is frequency and one is power. So whenever you are applying 11 kV and secondly you are getting 440, this does not mean that transformer is a converting device that is converting your voltage levels, but it is transforming device. It is putting your 11 kV, it is actually putting your 11,000 volt to 440 volt, but at the same time the current I1 which is lesser here is also getting increased here. Okay, so this is also true, and when you are multiplying this voltage and current, the power is going to be equal for you. Okay, the power is almost equal at the primary side or at the secondary side. The power if you obtain the power, if you calculate the power, that would remain equal at the both of the sides. I hope my concept is now clear. Now it's time to re-summarize this video, what concepts we have learned so far and what these things are. Okay, now let's summarize this video. So we started with what is the transformer, what these things are. Now let's coming back to the basic concept of this. Now let's come back to the basic image, what you see at your society level or at whenever you are traveling outside. You must have come across a device that is hanging on a pole, that is installed on a pole, and it looks like this, and you don't know what these things are. So I have explained you what these things are. One thing, the main device, the main component that is put over this pole, this is nothing but it is called a transformer. Okay, the wires these are going, these are nothing but R, Y and B. These are three wires, three lines, R, Y, B, three phase line. This is nothing but three phase line. So two things are clear for you now. One is the thing you are looking at, someone asks you that what this thing is, then you can directly tell. So now onwards, if anyone asks you about this device, what this is called, then you can directly tell that person that this is nothing but a transformer. Okay, And if he asks you what this device and how this works, that is also been explained in this video. Now if someone is asking you what this is, then you can tell them this is bushing, and these things are, this is nothing but, I think, isolators. Okay, these are isolators. I have already covered in my last video. So basic things are clear for you. Okay, these are radiators. This finch type of structure, this is nothing but radiators. Okay, now if you come across this device like this on anyway, if you look at this device, then this is nothing but conservator tank. This is the main tank, this is radiator, these are bushings, and these are RYB lines. So these basic things are now clear for you. So you have come to know so many things in this video. Okay, I have also explained you that how this transformer is installed at your distribution line, how this transformer is installed, how this RYB are coming, and how this is getting transformed to 230 volt, that is Indian standard voltage. Okay, how this is converted to 440, then 230, and okay, frequency is always constant. Okay, 230 volt, and this is also different for different countries, like 120 60 hertz for United States. Okay, so this also been explained in my slide number 2. And slide number 3, I showed you that different transformers in different countries, how these transformers are looks, and what this power transformer is. Okay, one thing I think left to tell you, that this power transformer is nothing but converting, or it is at the it is at the first stage. It is at the first stage of generation. It is at the first stage of generation. I mean, whenever there is a power plant, or maybe this is thermal plant or hydro or nuclear, at the power plant level, whenever the electricity is generated by the AC generators, in order to elevate this, or in order to step up the electricity that is generated, the power transformer is used. This is into the level of like 220 kV, 750 kV. So this is for that only. So power transformer, the basic function is same, but it is placed at some different stage of the power transmission. There is a variation in stage, the operation is same. There are some more, it is equipped with many features, some other features than distribution transformer. It is having one breather. It is having many control equipments installed in this transformer. The radiator plates are many. So it is actually as per the voltage level of the transformer, the basic function is same. I also explained you how the transformer in abroad looks like, what these bushings are. This is already explained and covered in slide number 4, how these bushings are and why these are called hollow insulator. Okay, these things also I have covered in my slide number 4. Now in slide number 5, I showed you this inside view of the transformer, how these windings are insulated. These windings are actually insulated. See, this is insulated with some paper. Just in order to, there are two losses in actually transformer: hysteresis losses and eddy current losses. Hysteresis losses are depending on the material of the transformer, material of the core. Okay, and eddy current losses, that are eliminated by this paper insulation. These are actually nothing but, there are strips of copper strips that are used in transformer, and these copper strips are insulated like this paper, and this is avoiding this is for preventing the eddy current losses. Eddy current losses are nothing but, these are into eddies. Eddies means, I will explain you some other day that how these eddies are developed, and how this is resulting into the losses to the transformer. These two losses we can cover. Just let me know if you want to know about the more details of the transformer, but I'm here covering in such a way that you can understand the basic functioning of the transformer. Now, in this explanation in slide number 6, I explained you the basic principle of the transformer. The basic principle of the transformer, I explained you how these cores are functioning, how, I'm sorry, in this slide number 6, I explained you the use of conservator tank, the conservator tank which is installed here, use of conservator tank and radiators. Okay, the radiators are used for splitting the oil. Actually, the oil is keep on rotating into the transformer through these radiators. Now, these oils are splitted into many ways. Like there is one flow of oil, the pipe is here, and these are radiators installed. Okay, now this oil is getting splitted into radiators. Whenever the oil volume is less and the area is more, this would get cooled down quickly. Okay, for cooling it quickly, the radiators are used for the cooling purpose of the oil. Okay, and why this conservator tank is used in slide number 6 we have already covered. In slide number 7 and 8 I have explained you the basic functioning of the transformer. Okay, the basic functioning of the transformer, and slide number 9 as well, 7, 8 and 9. So I am as now summarizing you on every single slide. Okay, so if I am summarizing you every single slide, then slide number 1, that is covering the basic notations of transformer, what these accessories are called. Slide number 2, that is for the transformer basic outline how the power supply is coming to the transformer, how it is converted. In slide number 3, some photos of the transformers and types of transformers we have covered. Slide number 4, bushing types we have covered. Slide number 5, inside view of transformer. Slide number 6, 7, 8 and 9, the working of the transformer and conservator tank radiators we have covered. So this video was all about covering the transformer technical details as well as the principle of working and everything that is should be known to as a general knowledge to every student for a transformer. So these things are covered in this video. I hope the video is clear to you, and I hope that you like this video. If you like this, then please hit the like button and please do subscribe to our channel Suraj Classes. Let's meet you again. Thank you so much for watching this video. Thank you so much.